Okay, this video is on part 3 of 4.6 and 4.7. We're going to take a look at inverses and how to write them and go back and forth from the do an exponent inverse and a graph and everything too. So when we have this exponential here, we have f of x equals 3 times 2 to the x minus 1. So the 3 is the coefficient, 2 is the base, x minus 1 is the power there. So we want to write it as y equals 3 times 2 to the x minus 1. I'm just writing that to clarify there. Now we're going to swap our x and y, interchange that. So we are writing it as x equals 3 times 2 to the y minus 1, because that's how we do the inverses. And then we're going to solve for y. So swap and solve y. Just a little review of inverse. So we want to undo this. So we're going to divide both sides by 3 to start with. So we have x over 3 equals 2 to the y minus 1. Okay, now to get y solvable, we need to use our log properties. In order to do that, we need to take the log of both sides. And I'm just going to do log base 2. So I'll undo that there. So log base 2, log base 2 of both sides. So now I have log base 2 of x over 3 equals y plus 1. So almost there, just add 1 to both sides. And now we have y, or I'm going to change that over to f inverse of x equals the log base 2 of x over 3 plus 1. Now that's my inverse function. We can see how they relate, that the log is an inverse of the exponent and vice versa. So the next step is to check to see if that's true, if it works out. So we have f of f inverse of x, which we need to find, and we're going to state its domain also. We need to think about, as we go through this, we should get an answer of x, but we definitely have to have x for the inner function has to work. So x cannot be, it has to be greater than 0. So now I have written this out as f of log base 2 of x over 3 plus 1 equals 3 times 2 to the x minus 1, where I'm going to plug in that whole expression in for x here. So I've done that down below, and now I have 3 times 2 to the log base 2 of x over 3 plus 1 minus 1. So inside here, I can really just remove these parentheses in the orange. Except I've lost my yellow. Okay, so now I have simplification. I can do add 1 minus 1, so that gives me a 0 there. And now I have this log I'm left with, so I can look at this separately here. Let's just draw a little thing around that. So I have a base raised to a base of 2 raised to log base 2 of x over 3. So then that just leaves me with the exponent. So I have 3 times x over 3. And now reduce that, and I am left with x. So this is kind of understood to have parentheses around it too, so it's okay to go ahead and use that property. So my x has to be greater than 0 based on my inner function of f inverse. So that's the log one. And that would be my answer. So you might like to try to do the other one as a classwork or just follow along with me. But we're just going to take that original function here and put it into the inverse. So we'll have f inverse of 3 times 2 to the x minus 1. And that will all equal 3 times 2. Now my x is going to be, oops, hang on, I'm going to write the inverse there. Log base 2, my x is going to be 3 times 2 to the x minus 1. I could use a dot or parentheses to notate that. And then I have that all over 3. And then I have a plus 1 here. Okay, so I have that all intact. Now what I want to do is start simplifying. So I can do 3 over 3 will reduce out. That leaves me with log base 2 of 2 to the x minus 1 plus 1. So now this log base 2 of 2 just leaves me with the exponent there. So I have x minus 1 plus 1. Those go to 0. So I'm left with x. And my domain on this one is x is an element of all real numbers, as that stems from the inner function, which is my exponential, and x can be any real number. So that's my answer for that one. Now we have a graph to do. So you want to start by graphing the, it says sketch f and f inverse and find the domain and range. So you can use the key points for the base 2 to the x exponential to start with, and then perform your transformations to put it in the right position. So I'm gonna just kind of go over that really briefly, but we'll get those down. I'll probably draw it out just to save time, and then I'll go through it and the process I used. Okay, so I've drawn in f of x right here. And what I did was figure out what 2 to the x is. I just wrote down the key points. I didn't bother graphing at all, but I'm using the pattern that we have. If we raise 2 to the negative 1, we're going to get 1 over half. So we know all these points are on this parent graph. I called it P of x. If I put 0 in, I get 0, 1. And if I put 1 in, I get 1, 2. You could do a few more if you want. But then I use transformations to graph our f of x function. So I have a vertical stretch of 3 because that's outside of the base exponent area. Then in the exponent, that affects the input. So I have x minus 1. So I have a horizontal shift right. So everything kind of moved just a little bit over. So I added 1 to all my x values, and I multiplied my y values by 3. And then I just plotted the points. Then I know that my inverse has to reflect on y equals x. So I'm going to just sketch that in there. And also I am interchanging my x and y. So I could write that just easily right here. I could write it as 3 half 0, and then 3 1, and 6 2. So just swap out, this is my f inverse and this one is my f. So just to keep track of that. And then I'm going to have my points. I have 3 halves 0. I have 3 1, and I have 6 2. And then I know my asymptote is going to be the 0, vertical asymptote, x equals 0. I can't have any zeros there. And then I can kind of eyeball here. I could have just graphed it based on the reflection if I wanted to, but let's write this a little bit neater here. Vertical asymptote x equals 0. Now my domain and my range, I've already kind of thought about that. So my domain for f of x domain is going to be x is all real numbers, because that was my exponential. So I can have any x value will work. But my range is always greater than 0, right? So my range for f of x is y is greater than 0. Or f of x is greater than 0. And then for my inverse, I have f inverse of x. My x is always, it has to be greater than 0. There's no value that I can put on there. Okay, so because just remember, this is really what my inverse is. I would have an x over 3 in there, so I have to have everything being greater than 0. So for my inverse, I'll write f inverse of x, and then I'm going to write y is, oops, I was on x, I forgot. X is greater than 0 for my domain, and then for my range, y can be any real number. And as you recall, your domain for your main function becomes the range of your inverse. Same thing, your range of your inverse, or domain of your inverse is the range of your original function, because you're switching the x and y's, right? That's why. So of course the input and output switch, that means the domain and range would switch. So that way it's kind of easier for you to tell. So this one you might like to try as a classwork. I'm going to write up some of the steps, but then I'll go through it, but I'll write the steps up and you can check against, mine against yours and see how you did. And then, so I'll hold the frame there for a minute and you can pause and check it all out. But then I'll just go through it with the laser pointer line by line so that you can match it up and get some tips if you miss something. One thing before you go off and do this as a classwork though, remember we have a coefficient on here. It's -1, and oftentimes that gets a little confusing. What do I do with that negative? Well, just multiply both sides by -1 and you'll get -x equals log of base half of y minus 3. So that way you're just starting off correctly. I just want to make sure. Think of that kind of like in the other one. You have to isolate your log first, okay? Okay, so here's my inverse that I got for the first stage of this. So I just exponentiated with the half here, base of a half, and I end up with f of x, or f inverse of x equals a half to the -x plus 3. So notice I have this vertical shift up 3, so that's going to change things a little bit. That actually means my domain of my original, if you notice, x had to be greater than 3, right? So that's affecting the input on the original. But when I go to do the inverse now, even though I just have an exponent up here, I have to make sure that my range, you'll notice, will be greater than 3 to match up here. So if those numbers aren't coming out right, you can tell. So now here is The next part is finding f of f inverse of x in its domain, part B and part C. I'll do those together, write them up, and then you can check. Okay, so here we have part B. I just plugged in the half to the negative x plus 3 into my log function for x. So I end up with negative log base half of a half to the negative x plus 3 minus 3. So that was with the original over here. Then I simplify this. 3 minus 3 is 0. Then I have this situation happening. That's my coefficient is the negative 1. And then the log base half of half is just negative x. So I get a positive x. And my domain is all real numbers. Go by what the inner function is. So we had established that earlier here. So now part C is doing the reverse, the vice versa. So I plug my log function into my inverse, which is the exponential. So I have a half to the negative log base half of x minus 3, and then plus 3 down on the bottom here. That's not part of the exponent. So I have this negative of my coefficients, so that just becomes positive. Then I have half to the log base half, so those undo each other, and I am left with x minus 3 plus 3, because my exponent just kind of comes down there. And then left with x, and my domain is x greater than 3, because it has to go by what the inner function is, which is my original, which is, in this case, is a log. Okay, so then now I'm going to write up the graph. Okay, so far on the graph, I figured out what my parent function would just be log base half of x. So I wrote out the key points for that. Remember, you're going to have 1 over b negative 1. You're going to have 1, 0, and you're going to have b 1. So then from there, I looked at what my transformations were for the f of x. So I have a negative there affecting my output. So that means I'm going to reflect on the x-axis. So all my y's will get multiplied by negative 1. That's what I have here in the pink. And then in my input inside these parentheses, I have a horizontal shift right. So that's going to change my asymptote as well. So I just added 3 to all my x values. And so I ended up with these points here and plotted them. And then I sketched in my vertical asymptote of x equals 3 and marked that. Now for the reflection, remember, the inverse reflects over the line y equals x. So I'm going to also know that my horizontal asymptote has changed. So I need to write that in. Let me do a different color here. We'll do orange. So that's going to be here. That I will have a horizontal asymptote instead of 0. I'm shifting up 3 on that. So that's going to be y equals 3 for horizontal asymptote. And then everything is going to just switch. So these points I would be plotting, maybe use red here. I'm going to have, instead of 5, 1, I'm going to have 1, 5. So that's right here. And instead of 4, 0, I'm going to have 0, 4. And instead of 3.5, negative 1, I'm going to have negative 1, 3.5. And then I approach that asymptote. So that is my f inverse, and the other one is my f function. So that's it for the graphing. I do need to state my domain and range again, just to be real clear that I have my domain for my function. So for f of x, my domain is x greater than 3. For my inverse, f inverse of x, I have my domain is going to be all real numbers. For my range, I have for f of x, my range is going to be y is all real numbers. And for my inverse, I'm going to have y is greater than 3. And you can really see that on the graph very clearly. So I hope that helps. That's going to be part 3 of the video set. And then I'm going to do one more problem here as an example, and then the word problems. I just think this one's getting pretty long, so it's a good place to stop on that page. Have a great day.